For lesson 6.4, we're going to be analyzing graphs and polynomial functions. So a couple things before we start the lesson is you're going to want to make sure that you have your calculator and that you have some graph paper. And so you could write down the title. And our essential question is, how do you determine relative max and mins, maximum and minimums? Okay, and we're going to be talking about the location principle. You don't need to write it down right here because I'm going to show it to you again on the next slide. And so here is our location principle. So basically what it's saying is if I have a point A over here that is below 0, negative, and I have a point B that is above 0, positive, somewhere in between there has to be a point that is a 0. You can't get from a negative to a positive without crossing over a 0. All right, and then we have some other terminology, relative minimum, relative maximum, and then we also have extrema and turning points. So copy down all the highlighted information. And then on this slide, it's got some information for you that it'd be a good idea to hit pause and just read through these. Okay, so let's start our problem. Graph this function. So the first thing you're going to want to do is write down that equation, or that function. And then let's use our calculator on this. So go to your calculator, type in the function, and we'll make a table for it. So I already have the function in there. And again, to do so, let me get this in the right spot here. I went to y equals, I typed in the function. If you're not remembering how to do raised to the third, you press the raised to key here, and then 3. And then we get, oh, I need to clear this. Then we go to our table by pressing second graph, and there's our table that we're going to copy down. So I believe it started at -4. Yes. -4. At -4, it was 5, -4, -3, 2. 5, -4, -3, 2. Get that back again. And then I've got 5, 0, 19. Okay, so we used our table, and now we're going to actually plot the exact points on a graph paper. So this is where you need your graph paper, draw an X and Y axis. And I don't think we're going to get that 19 in there. So we start by going over 4 to the left, up 5. Over 3, down 4. Over 2, down 3. Over 1, up 2. 0, up 5. 1 is 0. And then 2 is back up high at 19. I'll just put it off the paper like that. And so my guess is that it's coming down. It's going up, and then, oh, I didn't go up high enough. Missed that. Got to go up even higher here. Then it comes back down, and somehow jets back up again. So it's just kind of connecting the dots. It would be a good idea, though, for us to take out our calculator and just press graph, see what that looks like, make sure we're on the right track. Oh, hold up a second. Did that go to -19? Did I make a mistake there? It did go to -19. That's the hard part of copied it over. I don't actually get to see it. Okay, -19. Therefore, it actually isn't up there. It's down here, way down. So then it's coming here and just shoots down. We'll put arrows at the ends of those. Okay, so now let's do another one. So go to your calculator, type in this function, and you should write this function on your paper as well. So I've typed it in there, and then I'm ready to look at my table. Second graph to look at your table. And let's figure out where my value needs to be. I need to start at -2. Maybe I can slide this over here. Okay, at -2, it is 9, -1, 1, -3, -7. 9, -1, 1, -3, -7. And then I need to go down to see my last point. 3 is at 19. And then I better just go back and check it. Make sure I actually copied them down right. Okay, that looks good to me. Now I'm ready to graph them. Oh. All right, graphing them. I've got -2 up 9, put a point. Over 1, down 1. Over 0, up 1. Over 1, down 3. Over 2, down 7. And then over 3, that's going to be way up high at 19. So the graph is coming down and then up and then down and then shooting up again. Okay, so we have to decide where are all of the zeros of this function. So zeros happen whenever it crosses from negative to positive. So looking at our function, when did it cross from positive to negative or negative to positive? So right here it crossed. So we would say between -2 and -1. Okay, notice I use my x's when I'm talking about it. Okay, it crossed again right here. It went from negative to positive. And so then we would say between -1 and 0. And then the next spot, it crossed again. So this would be between 0 and 1. Okay, it doesn't between 1 and 2 because that's just negative to negative. But between 2 and 3, it does again. 2 and 3. All right, and if we wanted to locate those on the graph, that one's between -1 and -2. That one's between -1 and 0. That one's between 0 and 1. And here is between 2 and 3. Okay, and then the last thing that we need to do is describe the end behavior. Okay, end behavior is looking at what is it doing at the ends of the graph. So as our x's go to -infinity as we go to the left, what's happening to our function? It's going straight up. So we'd say as x goes to -infinity, f of x is going up, so it goes to +infinity. Okay, how about the other direction? If we're going to +infinity, as x goes to +infinity, if we go to the right, what happens to the graph? It's going up as well. F of x goes to +infinity. Okay, our next one. So we've got this graph, and we're going to estimate its relative maximums and relative minimums, and then describe the end behavior again. So let's go back to your calculators and type this function in. Oh, I'm not going to be able to do it that way. Let's bring it up here. Y equals. Okay, and so there I have the function entered in by the wonderful powers of the pause button. All right, and let's take a look at our graph. All right, we have a relative maximum right here. Because it goes up to a high point and then goes back down again. And then we have a relative min at that point because it goes down, but then it ends up going back again. So we need to find those. So we are going to use this function on our calculator. So we are going to press second trace. And let's find the maximum first, which was number 4. So it says left bound. That means I need to go anywhere on the left side of it over here. So I'm going to press the over key, just a couple, and hit enter. Now it changes to the right bound. So I need to go right of the maximum, right in that section right there. So I go over just a little bit. Doesn't need to be too far. Hit enter. Okay, then guess, move my cursor close to it. Press enter, and there it is. And it disappeared on me because I pressed enter twice. I'm going to hit pause and then do it again. Okay, I got it back again now. So our maximum is at 5. So let me slide this over. What does the equation say? Estimate the x-coordinate at which the relative maximum and relative minimum occur. Okay, I actually was saying the y-coordinate, but it wants the x-coordinate. So relative max is at x equals 0. Okay, then we can do the minimum. Let me clear that off. And we'll go second trace. And this time we'll choose the minimum. Okay, it says left, so we have to go to the left of the minimum, which is somewhere over in that section. So I'm going to move it over just a little bit. That might be just a little bit too far. There we go. I'll hit enter. And then right bound. So to the right of the minimum would be over here. So I press the over key. Once I get over there, I can hit enter. Guess, move it to the bottom. About there. Hit enter. And okay, my calculator says 1.9999. We just have to know that the calculator's having a little trouble with it, but really the answer is 2. Your calculator might say something like 2.00008, some random number at the end, but we just have to know that means 2. Okay, so let's go back here and write relative minimum. Was x equals 2. And then it says describe the end behavior. So back looking at our graph. For the end behavior, we say as x goes to negative infinity, what's the function doing? It's going down. So as x goes to negative infinity, f of x on the left side is going to negative infinity as well. It's going down. And then we look at the right side. As x is going to positive infinity, our graph continues to go up. So as x goes to positive infinity, f of x goes to positive infinity also. Now, if you haven't done so, if you didn't write down those calculator steps, you might want to hit rewind on this and then write down the keystrokes so that you remember how to do this later on your calculator. Okay, the next problem. We have a function here that is representing the weight of a patient during a 7-week illness. So let's put that into our calculator. And you can hit pause to do so. I've got it in there, and I'm going to hit graph. Now the thing is that not all of this graph is going to make a whole lot of sense. So we're going to go to our window. X's represent the weeks, so we only care about from 0 to week 7. And then if you look at this, we know that this value here always represents our starting point or our y-intercept. And so that's what the weight needs to be around. So how about if we go a little bit below the weight of 110, so maybe 90 up to 130. Let's look at a graph like that. So there we can see the patient's weight. So you can copy that down. I'm going to just take a picture of it. There's a graph of our equation. You could use a table and make a more precise one. Next question. Describe the turning point and the end behavior. Well, when is the turning point? It's right here. Turning point is week 4. End behavior, what's happening at the end? It's increasing. It's going to positive infinity. All right. And what trend does this suggest? That it's going down till week 4, and then she's continuing to gain weight. And do you think this is going to continue forever? No, she's not going to end up in infinite weight. It'll probably just continue for a little while, and then it will probably level out again. Okay, that's it for this lesson. You can write your questions and your summaries.